Alright, okay, so sets. Are we ready?
Sort of.
Okay, so you got given these yesterday. Alright, so sets. Brand new topic. What is a set? A set is a collection of objects, numbers, ideas, can be anything. Okay, so a set can be anything. Each different number of or whatever is in the set is called an element or a member. Okay? If we're defining a set, we can just define it by using a list. Okay, so we would just list what's in the group. Notice these symbols here are fancy brackets that we use when we're looking at sets. Okay? Essentially, there are forwards S and a backwards S. Okay, so it's or some people do it, can't do it with like a speak or something. Okay, whatever you do, try and make it look like a fancy pants bracket, not just a normal bracket. So I've got a list here, just numbers. This would be known as a finite group because there are a certain number of elements to that group. Okay, if you're listing things, the order of it doesn't matter. Numerical often helps the person marking it. Remember, you're trying to please the person marking it because they're marking a lot of pages at once.
Is there a difference between elements and numbers?
No, same different. Okay. You need to just make sure that if you're listing something, that you're only writing numbers once. So you would have, if for some reason you came across the number 4 twice, you would only write it once in your group. Okay. You could have a list show a pattern, so 3, 6, 9, 12. Notice this one's got commas on the end. Okay, that indicates that it's going on forever, because what would these be? What are these?
Multiple of 3.
Nice. And that would be an infinite group. Okay, so they go on forever because it's not, because they've got the dots on the end. As I've said, or as I said, as we described this one, you could just use a phrase. So multiples of 4. Now, this says here all multiples of 4. That will have a restriction on it. Okay, now the restriction on it is in a few pages' time. I should have mentioned it here. Okay, so within the universal set. So I'm going to write this here, and then you'll be able to look at this later when we talk about the universal set. Okay? So whilst we say all multiples of 4, whenever we're looking about sets in Venn diagrams, we're looking at only the universal set that they've defined. Defining them, we might use an algebraic expression. Okay, so I did talk about this briefly when we were looking at domain and range. This here would express that we're looking at values of x between 3 and 9. Do you remember that's how we would write that? Yes? Do I include 3 and 9? Why not?
No, because
Do you want to call a friend?
that's because there's no line thing.
Good. So had there been those things, or had there been one of those on one of them, you would have included the 3 but not 9 and so on. Okay? So just be aware that they may describe things in any of these formats. You just have to make sure you understand what they're getting you to look at. Okay? This symbol here means it's a member of. So if you see an E, it means a member or element. Okay? It's got a line through it. No guesses. It means it's not a member of a set. Okay? If you've got a circle with a line through it, it means it's an empty set. Okay, what do I mean by all of those things? Well, looking at these as examples, if I were to match the things with the correct statement, I need to say that something is a member of fruit. So of this list here, which of those would be the member or an element of the group or set fruit?
Bananas.
Bananas. Okay, so bananas would be an element of the set fruit.
What about like triangles?
What made you choose bananas?
Sorry. Are we good with that now?
Yeah.
Okay. Okay, so the next one, what would I write for the next example? Red, so you want to write red, green, blue?
No, green, blue.
You want to write green, blue?
Red. It's not purple or orange.
Okay, so remember, this one here said fruit. So you could choose anything that would be called a fruit, yes? This one here, it's a finite group. It's only red or purple or orange. So whilst green and blue are also colours, this is the only thing that would go here. Yes, do you understand that? If this had said colours, you could have put the green and the blue down there as well. Yes? But it didn't. It just, oh, shush now. Oh, Lord above. It just said red, purple, orange. Okay? So if red, purple and orange are my only choices, of this list up here, red was the only one that would be a member of that group. Does that make sense now?
Triangle.
It says square is not an element of. Okay, you could have pretty much any of those things.
Boys in your luck and a beach.
Other than quadrilaterals. So yeah, I'm going to put triangles just because I want the other one to go somewhere else. Okay, so square is not an element of triangles. Okay, some group would be classed as an empty set. Which?
Boys in your luck and a beach.
Okay, this would be classed as an empty set.
But technically you can do anyway.
No, because colours, quadrilaterals would not be an empty set. Quadrilaterals have lots of things. Yes, so quadrilaterals would be any quadrilateral, rhombus, square, parallelogram, etc., etc. But there are no boys in Year 11 at VHS.
What about that?
Right.
So that's how we bring it.
So that wouldn't be an empty set because red would be in your set. I'm not
The empty set sounds like a meaning.
okay, well, go ahead and make one. We'll get it right
What's
later.
the name of my...
So this is describing a set. Okay? So if we were to describe a set, we can use colours, we can list some things, we can do anything. But if you had red as a set, then that would indicate that red's probably going to be in your set. Therefore, it's not an empty set. This here,
So it's just something that doesn't exist.
correct, yes.
So,
Sorry, that would be a much simpler way of saying it. Okay? So, what things would have nothing in them? What can you not list anything in them? Okay? And boys in Year 11 at VHS would be one of those examples. Okay? So far, so good? Alright, symbols. So here we go. This is where we come to the universal set. So this fancy pants E.
ooh.
Okay, so I would normally just do a little extra curl and then backwards reaction essentially. Okay, so that's your fancy E, and that indicates we're talking about the universal set. Now, every question that you do on sets and Venn diagrams should give you or state the universal set. The reason being is because that's what we're always looking at. So it limits the population of things being considered. So if we went back to this, when we talked about here, we said all with multiples of 4, you would be limited by your universal set. Because they might say they're looking at numbers between 0 and 20. Okay, so you're only actually looking at the multiples of 4 between 0 and 20. We've said this E means member of, element of. Okay. This symbol here, not used so often, but it may come up. It means there's a subset. Okay. So G was the set 1, 2, and 3, and H was the set 1, 2, 3, and 4, then G is a subset of H, because this group here completely go inside this group. Does that make sense? Now this comes up a lot, and lots of people forget it. When you see the letter N in front of a bracket, okay, that's essentially telling you or asking you how many elements are there in that set. So this would mean that set J, whatever set J is, has 4 elements in it, because the N is saying how many elements are in that set, and that's equal to 4. This symbol here, like an upside down horseshoe, means intersection. Intersection. That means that which items or which elements are in more than one set. Okay, so English is a real battle here, in that you have to think carefully about the way that you're saying these things. So this identifies the elements that are in both sets. Okay, so set A, but also in set B, for example. Okay, so elements that are in set A, but also in set B. U, okay, means the union. This identifies all of the elements in more than one set. So A union B would mean everything in set A, but also in set B. Okay, do you understand the difference? So if you just said A and B, it's not making it clear. This intersection means it would be in set A, but also in set B. Okay? So which numbers or things are in both of the sets? This means you would list everything in set A, but you would also list everything in set B. United. Everything as a whole. No, so they will be asking you questions. So let's look at this as an example. So if this is my set A, this is my set B. I want to know A intersect B. So that means which numbers are listed in both of these sets.
Oh, it's like A and
Yes, yes. Okay. 5, 6, and 7. We all happy with that? So which are in both sets? Now A union B means we're going to list everything that's in A, and we're also going to list everything that's in B. So we would have 2, 3, 4, 5, 6, 7, 8, 9. I don't know why my 9 didn't write. Now, please note that I haven't listed them twice. Even though the 5, 6, and 7 are repeated, I only listed them once. Do you see that back there? So A intersection B is 5, 6, and 7. A union B is 2, 3, 4, 5, 6, 7, 8, 9. Okay, so far so good?
is the A and
Because it's A and also B.
no, the first one A, whatever that is B.
Intersect B.
So 5, 6, 7 is the
Because they're the only things that are in both of the groups. That they,
A and B, like R and B.
yeah. But it's hard because if someone says A and B, you might think A and also B. Like it's anyway. You just need to be clear what they mean. I always try and remember the U means union, united, everything all together. Okay, you're all happy, merry, excited. N intersection, so it kind of looks like an N, and so it's the intersection where they meet. When asked to list members or elements for set, you should always check the universal set, make sure you've included all possible values. Okay, so for example, if you're asked to describe things, okay, you might be asked to describe P intersect Q. So they told you that P is just cars. Q would be red things. Okay?
Red cars.
So this would be, as you said, red cars. However, this is where this bit comes in.
Wait, why? Because it's
Red cars in Bermuda.
Red cars in Bermuda.
oh.
Okay? So this intersection would be red cars. But the fact that we're only talking about things in Bermuda, or what, should I have capital B?
Because it's something in both P and Q.
Correct, that's where the red cars come in, okay? But we must make sure we clarify that it's only red cars in Bermuda.
What would it be if it was UQ?
All cars and all red items in Bermuda. Okay?
Wait, where does the in Bermuda come from?
The universal sector.
What does that mean? There has to be something. I heard you explain it, but I just need to it means that
So that's the population that we're looking at. Okay? So we could happen. Okay? If you see the dash, it means the complement. Okay, so if you see a dash, it means the complement of it, which means that anything that's not in that set. Okay? So, for example, if we had here P dash, it would be anything that was not a car in Bermuda. Does that make sense? So complement means not. So if you had the dash next to it, it means anything other than those things.
sorry, you're talking.
Would just be red cars and red things in Bermuda.
No, it would be not cars in Bermuda.
So you just say not.
It's not a car.
You just add not.
You just use the word not. Yeah.
So it's with numbers.
Nothing to do with red things.
How do you mean how to
I'm
use
pretty
it?
concerned about how to use these numbers.
I'll show you some more examples.
With numbers. Okay.
Okay?
Wait, so you say red shoes in Bermuda? Is it anything that's not cars?
No, darling. So if it was, following on from this example, if it was P dash, it would be not some, okay, items, not cars in Bermuda.
It's gonna be like with numbers.
Okay, sometimes yes, but the whole thing is that sometimes it's not. You're literally just asked to describe stuff, okay?
Items that are not cars in Bermuda.
Yeah,
Can I say items that are not cars in Bermuda or items?
you can say items that are not cars in Bermuda, sure.
You don't
I
have to
was
say
being
not.
lazy.
Say not.
You just have to say not. But specifically, you can't, if the other part of this was the red thing, you have to just ignore that if they're just talking about P dash. Okay, so if they're just talking about P dash, it just means you're focusing on that set. It doesn't matter what the other set was. So the fact that this said red things, neither here nor there.
So you just ignore it.
Yeah.
So we have to put that instead of the car.
No, you wouldn't.
Wait, so what if it?
Yeah.
What if it says P with the dash, P dash and Q? Then you say red things
Oh.
that are not in Bermuda?
Okay, so if it said P dash intersect Q,
Yeah.
you say things that are not cars,
But are red in Bermuda.
but are red in Bermuda.
That's like a whole essay.
Okay, but that's a very good question. That's come up that you're asked to describe
Can you
that.
just say that one more time?
Yeah, so things that are red but not cars in Bermuda. Okay, that's an awesome question.
You're welcome. I'm curious.
Now, I think we should have a party. The questions that we're going to focus on for now are going to look more similar to these kinds of things. Okay, so we're going to be either describing sets or identifying what intersections are, etc. Okay? And then we'll look at Venn diagrams, I think, next lesson, because I don't want to do too much without the other people. Okay, this is just a diagrammatical way of showing sets and their linkage. Okay? So let's do some questions from the text. Good.